Hey guys, Miss Albanese. Lesson 7, Module 6, ready to go. Today our target is I can represent measurement data with line plots. We've been doing line plots already. We did one yesterday, or well, a couple of days ago, I guess, but let's take a look at, today you got a pattern sheet. Don't forget to do that. Let's go here. Let's count by halves and fourths. Now to count by halves, we know that 2 halves is 1, so that's where we'll start. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, hope you're saying it with me, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves. Now let's count by fourths. First let's find the fractions that equal a whole number. Let's see, if this is 1 half, then 2 halves would be what? Would be 1. 3 halves would be 1 1/2. So 4 halves would be 2. 5 halves would be 2 1/2. So 6 halves would be 3. 7 halves would be 3 1/2. So 8 halves would be 4. 9 halves would be 4 1/2. So 10 halves would be 5. 11 halves would be 5 1/2. So 12 halves would be 6. There are 2 halves in every whole. 2 halves to make the whole, 2 halves to make the whole. Okay. Let's count by fourths to 12 fourths. As I show them, call them. Ready? And 1/4, 2 fourths, 3 fourths, 4 fourths. You call them. "11 fourths and 12 fourths. Hopefully you were saying them as I was putting them up on the board. Okay. Let's find the fractions that equal a whole number. Count by fourths again, but say the wholes when you get to them. Well, we already know that 4 fourths is 1, don't we? We've studied that already. So that's 1, 2, 3, 4 fourths as a whole. So that means there's going to be 4 more in 2. So let's use this like a number line. 1, 2, 3, 4 is going to be 2. So 8 fourths is 2. 1, 2, 3, 4. And that shows me that 12 fourths is 3. Now, I see a pattern. Who sees it with me? I see that 1 times my denominator is 4, which is my numerator. And I see 2 times 4, my denominator, is 8, which is my numerator. And I see 3 times 4 is 12, my numerator here. So I see a pattern that shows some multiplication, or I could say it shows division, because 12 divided by 3 equals 4. And 8 divided by 2 equals 4. And 4 divided by 1 equals 4. So anytime you see multiplication, you see division. And anytime you see division, you see multiplication. Here's our application problem. Oh, this is a fun one. This chart shows the length of straws measured in Mr. Hahn's class. How many straws were measured? Explain how you know. Well, let's take a look at it. This chart, see, I see 4 3/4. That's a big number. Do I see anything bigger than 4? Oh, I do. I've got to find the biggest number to know how many were measured. If I said 3 were measured, would I be right? No, because if I said there were only 3, you see here, there's 4, 4.5, and there's 5. So we know we have to have at least 5. Okay, what's the smallest measurement on the chart? Take a look at the chart. What's the smallest measurement you see? Would it be 3? No, I see something smaller than that. Would it be 2 3/4? I don't see anything smaller. I don't see anything else that has a 2, and that 2 is the smallest whole number that I see. So 2 3/4 would be the smallest. Let's find the greatest. I see 4.5. I see 4 3/4. Oh, but then I see what? What do you see that's the greatest? If you look right down here, you see 5. 5 is the greatest. Were the straws measured to the nearest inch? Were they measured to the nearest inch? No, because I see some 1/2 inches in there, and I see some 1/4 inches in there. So they were measured to the nearest 1/4 inch. How do I know? Well, because I look at it and I see that there are 1/4 inches, and that is the smallest that I see, so I know it's 1/4 inches. So let's use those lengths of straw measured in Mr. Hahn's class. And we've got a number line here. We're going to use it to make a line plot. First, I'm going to determine the scale. Well, we've already said that we're using 1/4 inches and that the largest one is 5. So if I used a scale of 1, would that probably be a pretty good idea? I think it would, because I don't need anything any larger than 1. And we only go to 5. So I think 1 would be good. So let's give ourselves 1, 2, 3, 4, 5. Okay, but then I have some 1/2 inches. So I have to go back and I have to put in some halfers. But I don't just have halves, do I? What is this? That's a 1/4 inch. So I've got to go in and put my little quarters here, halfway between my halves. It's a 1/2 of a half. There we go. And then I have to plot the data and give it a title, unit label, and key. Okay, so my key is going to be kind of my unit label. I'm going to say each X equals 1. Okay, so if I have Let's start with 1. Do I have any 1s? I don't. Do I have any 2s? No. Do I have any 2.5s? No, but I do have a 2 3/4. How many do I have? Well, I only have 1. I want to go ahead and mark it out so I know I've used it. So I'm going to go 2 1/4, 2 1/2, 2 3/4. I'm going to have 1x. Okay, what's the next unit up? Would be 3. Oh, I have 1 3, 2 3s, no more 3s. So I come to my 3 and I have 1. And then on top of it, I put 2. Now, I put it on top because remember, we're trying to look to see the tallest one. If you just look at it quickly, you can tell which one is the greatest. So you have to stack them on top of each other going upwards. So that was 3. My next unit's going to be 3 1/4. So let's see, 3 1/4. Oh, I've got one there. There's 3 1/4. Oh, and there's a 3 1/4. So is that all of them? Okay, so I have 2 that are 3 1/4. Remember, you got to keep your x's level so that you can see easily how many has the greatest or the least. Okay, so that's my 3 1/4. My next unit will be 3 1/2. So let's see, 3 1/2. Oh, 3 1/2. Only 1. 3 1/2. Okay. 3 1/4. 2/4, which is a half. 3 3/4. That's what my next one would be. So, 3 3/4. 3 3/4. Looks like that's it. 3 3/4. I have 2 of them. There's 1, 2. Okay, my next unit's easy to see. It's a 4. And that 4 is actually kind of high. So I'm going to take my eraser and I'm going to put my 4 a little lower. Get my pen back because I don't want to interrupt my flow of my X's here. So I've got to look for my ones that are 4. There's a 4. There's 2 4s. 3 4s. Okay, so far that's the most. 1, 2 4s, 3 4s. Okay, my next unit is going to be 4 1/4. So I'm going to come up here, 4 1/4. There's 1, and there's 2. So 4 1/4, I have 1, 2. Okay, 1/4, 2/4. I know 2/4 is a half. So I come up here and I find 4 1/2. There's 1 there, 2, 3. Yep, 3. And there's a 2, 3. So now I have 4 and 4 1/2 that both have 3. So far, they're the greatest number of inches. Okay. Let's see. Next I have, that's 1/4, 2/4, 3/4. 4 3/4. There's 1 that's 3/4 and 2 that's 3/4. 1, 2. Okay, so I've got all but the 5 done, and look, I did it again. I'm going to come up here and erase that 5 and move him down a little bit so that he doesn't get in the way. probably should have labeled them underneath, would have been a better way, wouldn't it? As a matter of fact, let's go ahead and let's label this 1/4, 1/2, and 3. Ooh, not a very good 3/4. It's kind of hard to do with the mouse. And then we have 1/4, 1/2, 3/4. Those 3s are rough. And then I have 1/2. Oh, sorry, 1/4. I almost said 1/2, didn't I? And then here's my 1/2. 3/4. 1/4. 1/2. And 3/4. Okay. So my 5. I've got 2 numbers left, and they're both a 5. So I had 2 straws that were 5 inches each. All right, so I have to, it said first determine the scale. We did that. We plotted the data, give it a title, unit label, and key. Okay, well, here's our unit label and key. And now we've got to, we plotted that, give it a title. Well, what would the title be? Here they used straw lengths in inches, which works for this table here. But what are we measuring here? The number of straws. Let's see, Mr. Hahn's classroom. So lengths of straws measured in Mr. Hahn's class. So we could use this label. And I'm not going to try to write it with this because it's really hard to write. But I'm going to say put that label right here. And that would be the label. Lengths of straws measured in Mr. Hahn's class. That'd be a great title for our line plot right here. Okay? So let's move to the next slide. And it shows you how you can, see they redid it here. Theirs is much neater than mine. Oh, and we forgot to label that it was inches. So they did that here. How many straws were at least 4.5 inches tall? Well, I can go to 4 2/4, which I know is 4.5, and say there was 1, 2, 3. And since every X equals 1 straw, I know there were 3 straws that were at least 4 1/4 inches. Look at that. I made another mistake. Looky. I'm good at that, aren't I? Take my eraser. Get my pen back. 4 1/4. So we got to come over here to 4 1/4. There's 1, 2. 2 straws. How many straws were taller than 4 inches? Well, that means anything going this direction is all taller than 4 inches. We don't want to count 4 inches because 4 is not taller than 4. It is 4. So I've got to come everything bigger than 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many straws were shorter than 3/4? 3 3/4. Let's see. There's 3 3/4. Don't count this because 3 3/4 is not shorter than 3 3/4. So I say 1, 2, 3, 4, 5, 6. Let's make sure. 1, 2, 3, 4, 5, 6. Yep. 6 are shorter than 3 3/4 inches because we know when we're going this way, we're getting smaller. When we go this way, we're getting larger. Which measurement happens most frequently. That means the most often. Well, we've got a tie. We've got 4, and we've got 4 2/4, which is the same as 4 1/2. So we're going to say 4 and 4 1/2. That's a little and sign. And which one happens the least frequently? Well, the least frequently would mean that it is the smallest amount of time. So we've got a tie on that one too. 2 3/4 and 3 2/4, which is 3 1/2. Let's see, 3 1/2. Okay, so moving on from there. Oh, time for the problem set. Okay, get out your scratch paper and your pencil and get ready to move on to your problem set. I'll see you on lesson 8.